Everyone, welcome back to the database channel again. So today we would be covering the complete end-to-end project, including the EDA along with the modeling part. So last time we covered different EDA, different models. So this is a complete of both. So let's get started. Again, the entire notebook is on the Kaggle. I'll share the notebook link in the description. And the data that I have used is the input data of the IBM. So they have an input data for the account receivable, where they have country, customer ID, paperless. This is a financial problem basically, with invoice number, invoice date, due date, different other features, and the paperless bill. The end goal of this problem is to see how many days late is the payment generally made, and how we can create a model that can tell us for which particular customer how many days or the number of time late the payment would be made as per their previous behavior. So let's get started. So this is again a Kaggle. By default, we have this cell in the Kaggle notebook where we have the input data. Then we are reading the input data from the Kaggle, and this is the entire data path as DF. Then understanding the data, seeing the sample 5, how the data looks like, country code, customer ID, paperless date, invoice number, invoice date, due date, invoice amount, disputed settle date, paperless bill, days to settle, and days late. So this is the predictor here. Let's get started. We print the columns, what are the all the columns and what is the d type of all the columns. Then we did the describe into a transpose to see for all the numerical features what is the count, what is the mean, standard deviation, minimum 25%, 50%, 75 percentile as the and the maximum value. Then we are seeing the data types. So multiple features are object refers to string, and others are integers. Then for the categorical column, means for the object columns, printing all the categorical column, we have customer ID, paperless date, invoice date, due date, disputed, settled date, and paperless bill. Then for the numerical columns, printing all the numerical columns here, country code, invoice number, invoice amount, days to settle, and days late. We are iterating in the columns, checking what are the type of NP dot number for the columns, and then printing it. Then again printing the sample, and then the columns. Then for as we discussed in the previous videos as well, for all the date related features, we try to convert into a date time format. So for that particular feature, converting that to date time, so with the help of pd dot to underscore date time function. Then for the standard due date, for the due date and the invoice date, doing the difference between the two to see the standard due date and its value count. Okay, so this comes from the business problem. This is generally a business understanding. When you would be working on multiple other projects, you will be seeing how these different variables are being calculated or created. Then doing the separation and normalization for all the date for dt dot month, convert that into the month and then divided by 12, and then creating a variable paperless date month in the same day for the day, the same way for the month, in the same way for the invoice date day. Then printing the data sample again and see the features that we have created are coming here or not. Then understanding and manipulating invoice amount feature. So firstly, the invoice amount feature, describe and t, and seeing the count, the minimum value, maximum value, and what are different values in different quartile. Then trying to create a function how we can convert the categorical values of the invoice into numeric. So numeric to category, sorry, converting the numerical values to category. So for the values are less than 25, we are writing return less than and equal to 25, and we had made different binnings or groups. For less than 50, so between 25 to 50, less than 75, between 50 to 75, and so on. Then printing the sample again and seeing the features, the invoice amount, the features that we have created is coming here or not, which is coming here, you can see it. Then with matplotlib.pyplot as PLT, we are trying to import and then trying to get a graph. So which graph? We are a bar graph. This is the title, and for the invoice amount. So with respect to the invoice amount for all the segments that we have made, between 50 to 75 is the largest. Just an analyzation of this. Then for the days late which are not equal to 0, then creating a date. Data refers to that we are segmenting that part of a data frame where the days late is not equal to 0. So people who are paying on time, we are excluding that data, and then seeing the data sample again. Okay, then understanding and manipulating days late feature. So with respect to the days late, we have imported a one more library, cborn. Either you can use cborn or matplotlib depending on the choice to size. Categorical plot, put here hue, disputed, kind of box plot we want, and for that feature. So now we can see what's the tradition and what are the outliers in between all the groups for days late and the invoice amount. Then converting the numerical to categorical for another variable days late as well, in the same way that we have done earlier. Then putting the plotting the days late column with respect to the value counts, again the bar chart to see. And again here in this bucket we have the maximum count. Then paperless bill feature, in this format we would be manipulating or understanding every feature like this. So paperless feature, we are checking the value counts again and then seeing the sample data. And here again seeing the different formats of paperless bill with respect to the paper, with respect to electronic, when the dispute is yes, when the dispute is no. Then country code features, all the categorical features we are trying to understand the same way. So country code features we have here, and all the numerical features we are trying to understand. Just correcting again. So with respect to the country code, this is a sample, and we have did the binary encoder. So the encoding we do, if you want a special video on encoding, please mention in the comment section. Then one hot encoding on different features: disputed, paperless bill, invoice amount. And then dropping columns related to date. Then creation of x and y. So for every modeling, x and y creations are very important. So y is the days late column. And then we are dropping the days late from the final data frame and creating the x. Splitting the data into train and test, we have used sklearn model selection train test that we have imported and used that to pass the data for x and y. Created 4 data frames. Analyzing x train and x test, y train and y test, how it looks like. Then doing the logistic regression model. So we're importing linear model from logistic regression, accuracy score, confusion matrix, classification report. And then this is, we are making a method or an object of logistic regression. We are fitting that on the x train and y train. We are predicting that on the x test. We are getting the accuracy score through the accuracy function, passing y test and y predict. And we are plotting a confusion matrix and the classification report. So after running this, the accuracy is around 61.9%. This is with respect to the true and the predicted label, how the confusion matrix looks, and with respect to each class, what is the precision, recall, F1 score, and support. So then we come to the end of this notebook, and going forward, we can do multiple hyperparameter tunings, multiple other things on the data analysis part, on the modeling part, to make our results much better. So thank you for watching this video. If you like this content, if you want more content like this, please like, share, and subscribe to the channel. And see you again. Bye.